Before we walk into reactions and synthesis, we need to realize one other classification based on structure. For alcohols, which has general formula ROH, a hydroxyl attached to an alkyl group, the primary structure means that only one of the hydrogens attached to the carbon that has hydroxyl on it is replaced by alkyl, or it's just a hydrogen. So some examples, if I give you methanol, it's a case of primary because you have CH3OH. If I give you, for example, ethanol, now one of these hydrogens is another methyl group, so it's a CH3CH2OH. So if you look at this carbon here, this one with asterisk, you see there is a H, there is a methyl, there is a H, and then there is hydroxyl. So these are examples of primary alcohols. A secondary alcohol, the second hydrogen is also replaced with another alkyl group. For example, if I put CH3 here, CH3, and you have only one hydrogen left on this carbon, this is example of a secondary. Now, how do you name it? Go after the longest chain, which is this here. So it's a propane, which on the second carbon you have a hydroxyl group. So it's prop2ol. So that's example of a tertiary. Now, if all hydrogens with the carbon with the hydroxyl group are replaced with alkyls, then you have a case of tertiary. So for example, if I put CH3, now R prime, R double prime could be exactly the same like in this case, or you could have another alkyl group. If you have something like this, that there is no more hydrogen left on the carbon with hydroxyl, your example of a tertiary. How do you name it? Then again, the longest continuous carbon skeleton is this, and you have a methyl group, and you have your important functional group hydroxyl. So this is a case of 2-methyl prop2ol. So example of tertiary, secondary, primary for alcohol. Next, let's look at haloalkanes. Now haloalkanes are RX. Now remember, X is either chloride or it's bromide or iodide. So it's a haloalkane. In case of a primary, you have all hydrogens attached to that carbon or only one alkyl group. So if I give you CH3Cl, this is example of a primary, and it's chloromethane. Now if I only put a alkyl group and two other hydrogens, something like this, CH2, CH3, then again you still primary alcohol because you still have two hydrogen left on that carbon, which is attached to chlorine. So this is chloroethane. Now if one other hydrogen is replaced with another alkyl, meaning you have two alkyl on that carbon attached to your halogen, then you're example of a secondary. So if I put my halogen bromine this time, put a CH3 here, put a CH3 here, and one hydrogen left on it, this is example of a secondary. How do you name it? Then again, go after the longest continuous backbone, which in this case is 1,2,3 propane. So this is 2-bromopropane. Now if the last hydrogen is also replaced with alkyl, then you're tertiary. So if we put CH3, CH3, CH3 attached to an iodine, this is a tertiary haloalkane. How do you name it? The longest continuous is this, and you have a methyl group and also your halo group here. So this is 2-methyl. I'm going to put iodo before this because we have to respect alphabet, so it will be 2-iodo, 2-methyl, and then last name propane. So example of tertiary, secondary, and primary that applies to haloalkanes, extremely important. for their reactions. Now, last, let's look at amines, which are related to ammonia. Then again, same sort of classification applies. If one of the hydrogens is replaced by alkyl, then your example of a primary. For example, if I put CH3 NH2, this is methylamine, and it's example of a primary amine. If you have two alkyls, one hydrogen left on that nitrogen group, then you are a case of secondary, CH3 and CH3H. Now this is dimethylamine. Sorry for the slowdown, my brain just froze for a second. Now if you replace the last hydrogen with also another alkyl, then your example of a tertiary, as simple as that. But extremely crucial to realize them, because then their chemistry and reactivity changes. This is example of a 1,2,3 trimethyl amine. A tertiary amine, a secondary amine has one hydrogen, a primary amine has two hydrogens left on it.